All right, here we go. Question number 13 from our Precalculus homework number 3 in MyLab Math. This is a matching question where we're going to have to match a logarithmic equation with its corresponding graph. So just some introductory stuff about graphing logarithms. Here I have written the equation for the basic log base 8 of x. And I did that because I noticed all of my choices are log base 8. What we can do to get the generic graph here is start with a value of 1, because we know taking the log of 1 always produces a 0. No matter what the base is, if you take the log of 1, you get 0. And so that's going to be an ordered pair on our graph. Notice that I have plotted that here in blue, 1, 0. The next thing we can do is let x be 8. Now that value matches the base, and that is going to be a nice number because we know when the base is matched, they cancel, and the exponent is the answer. So when those bases match, here the exponent is going to be your y-coordinate, and that point is plotted on our graph here. And we know that we cannot take the log of 0, and definitely not negative numbers, so our vertical asymptote here is going to be on the y-axis. So what I've written right below this is our general form of a log function, where our base is 8. That's going to affect the amount of curvature. The h is going to represent the location of the vertical asymptote. Notice in our equation h is 0 because we have just x, and so the vertical asymptote would be located at x equals 0, which is the y-axis. The k would represent a vertical shift. So if there was a number out to the side, say +2, that would take this blue dot and shift it up 2, shifting the entire graph up 2 spaces. So using the knowledge of this generic graph for log base 8 of x and our knowledge of transformations, we're going to see if we can't drag and drop these equations where they need to go. The first equation we're going to graph is y equals log base 8 of x. It appears that none of these graphs here look like they're curving up to the right with the y-axis as an asymptote. So looking at the next 4 graphs, look at this. Number 69 does have the y-axis as an asymptote. It does have an x-intercept of 1. Like our standard graph had, and it appears that it does go through the point 8, 1. So I'm going to go with 69 is y equals log base 8 of x, and we're just going to drag and drop him. Next, y equals log base 8 of x minus 1. Since this minus 1 is outside of the log, that's going to be a vertical shift down 1. So what we want to do is we want to recreate the graph of number 69 shifted down 1. So instead of having an x-intercept of 1, that point is going to drop down 1 space, much like it does here on number 71. So this also has the y-axis as the asymptote, but the x-intercept has been dropped down 1, and none of the other graphs even have the y-intercept as a vertical asymptote with the graph curving up to the right. So I'm going to drag and drop him on number 71. Let's do this equation next. Y equals log base 8 of x minus 1, where the minus 1 is inside the logarithm. That is going to represent a horizontal shift, plus is left minus is right. So here we want to recreate the graph of number 69 because that's our standard log base 8 of x, but we want to shift that to the right 1. So then the vertical asymptote would be at 1, and the x-intercept would be at 2. And the only graph that looks close to that is number 66, where the asymptote has been shifted 1 and the x-intercept is at 2. So this equation is going to drop right in there for number 66. Next, let's do y equals negative log base 8 of x. We know that from our transformations, a negative in front of the function will do a vertical flip over the x-axis. So what we want to look for is the graph of 69, but flipped vertically, so that the graph is going to come down, approaching the y-axis, through the same x-intercept, and then curving down to the right. And we don't have to go too far to see that that looks a whole lot like number 70 here. Coming down along the y-axis, going through the x-intercept of 1, curving down to the right, I believe that's going to be number 70. So here with the vertical flip, drag and drop that to number 70. Next, let's do y equals log base 8 of negative x. According to our transformations, if there's a negative directly attached to the x, that is a horizontal flip. And so here we want to go back to our basic graph and consider a horizontal flip, which would be across the y-axis. So now we're going to have a graph that approaches the y-axis as a vertical asymptote, but curves up to the left, and the x-intercept would also flip over to be -1. So looking for a graph that comes up along the y-axis with an x-intercept of -1, that looks a whole lot like 65. So we're going to drag and drop him in there. All right, let's do this graph next, where we have a negative log base 8 of negative x. That is going to incorporate a vertical flip and a horizontal flip. Okay, so if you can imagine this graph flipped vertically, it would come down to the right, and then flipped horizontally, it would come down to the left. So we need an x-intercept of -1, but the graph needs to come down to the left. And that looks like number 67, having the y-axis as the vertical asymptote, an x-intercept of -1. This graph would represent a vertical and a horizontal flip from the original. So again, we're going to drag and drop him right there. And I've only got 2 more to go. So let's see what we've got. This particular equation has a negative in front of the log. That would represent a vertical flip, and the 1 would be a vertical shift. So if we go back to our standard function 69 and do a vertical flip, we're going to need a graph curving down to the right, but shifted vertically 1 space. And we've only got 2 choices now, and this number 72 doesn't even curve down to the right like it should. So that means that this equation with the vertical flip goes here, drag and drop, and by process of elimination, this one has to go with number 72. And that's kind of the way you do that. So if you have any questions or comments about anything covered here in the matching problem, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.